The Arctic's angry fever, why our planet's AC is broken. We're about to head to the very top of the world for a real-life climate detective story, because something has gone really, really wrong with the planet's air conditioner, the Arctic. So just picture this for a second. What if your home's air conditioner suddenly started blasting heat? I mean, it's the hottest day of the year. You crank on the AC, and instead of that sweet, cool relief, it just starts pumping out furnace-level heat. Your place would become an oven, right? Totally unbearable.
Well, believe it or not, that's exactly what's happening to Earth's air conditioner, the Arctic. That whole nightmare scenario, it's not just some thought experiment. It's literally the reality for our planet right now. The Arctic, the system that's been our giant AC for thousands of years, is now actively working against us. It's heating things up. And the crazy part is, scientists have actually pinpointed the exact moment it all went haywire.
So this brings us to the first big piece of the puzzle, a climate tipping point. You see, for so long, we've heard about the Arctic warming kind of slowly, gradually. But what scientists have realized is that's just not the right way to look at it anymore. Something has changed, big time. So, a team of what you could totally call climate detectives from all over the world, they dug into decades and decades of data. And what they found was this one critical moment in time, right around the year 2000. It's like the entire Arctic climate system just completely floored the gas pedal. No more slow crawl. This was a sudden lurch into high gear.
And I mean, just look at this image here. It really visualizes that sudden shift perfectly. On the left, you've got before 2000, where things look, well, relatively calm and stable. But then you look at the right, after 2000, and bam, it's just chaos. You can see this massive, explosive jump and how often these extreme events are happening. It's not a gentle slope, folks. It's a straight-up cliff.
And when you look at the actual numbers, it's pretty staggering. The chances of warm Atlantic water rushing into the Arctic, that jumped by almost 77%. The risk of a huge sea ice collapse, that went up by over 83%. What this means is, these events that we used to think of as, once-in-a-century kind of things, they're now happening several times a decade. That's a huge change. So the big question is, why? How did this happen so fast? Well, those climate detectives, they figured it out. They uncovered this core mechanism, and it's this powerful one-two punch that they call the push and kick effect. Okay, so first up you've got the push. And the easiest way to think about this is what they call the black t-shirt effect. You know how if you wear a black t-shirt on a sunny day, you get way hotter than if you wear a white one? It's the same idea. The Arctic's bright white sea ice is like a giant white shirt reflecting sunlight back into space. But as it melts, it reveals the dark ocean water underneath. That's the black t-shirt. It just soaks up the sun's heat, which melts more ice, which reveals more dark water, which soaks up more heat, and on it goes. A totally vicious cycle is born. And yeah, this diagram here shows that cycle perfectly. You see it right there. More sun gets absorbed, the ocean gets warmer, which means more ice melts, and the whole feedback loop just gets stronger and stronger. So this slow, steady, long-term warming is the push. It's what's been nudging the Arctic closer and closer to the edge of a cliff. But the push alone isn't the whole story. That's where the second part comes in, the kick. Because now that the Arctic has been pushed into this really fragile, unstable state, normal, everyday weather events, just a regular storm or a current of warm air, they act like amplifiers. They suddenly have this supersized, destructive impact. And this little cartoon illustrates the idea just brilliantly. Think about it. Before, a small kick from a weather event would just, make the snowman wobble a bit. No big deal. But now that he's been pushed right to the very edge of the cliff, that exact same little kick sends him flying into this massive, chaotic vortex. The cause is the same, but the effect is catastrophically bigger. All right, so let's get to the big one. Why this matters to you. I mean, the Arctic isn't a bad way, we get it. But why should someone in, say, North America or Europe or Asia really care? Well, the simple answer is because what happens in the Arctic absolutely does not stay in the Arctic. To put it bluntly, the Arctic's fever is contagious. It doesn't just stay put. It actively exports chaos south, messing with atmospheric patterns and sending unpredictable, chaotic weather all over the rest of the planet. And this stuff probably sounds familiar because it affects you directly. We're talking about those insane heat waves in North America, or those severe cold snaps, the polar vortex that can just paralyze Europe, or the completely unpredictable winters and summers we're seeing in Asia.
More and more evidence is pointing to the fact that these aren't random events, they're the direct consequences of an unstable Arctic.
And then there's this number, 7 meters. That's about 23 feet. Let that sink in. That is how much global sea levels could rise if the Greenland ice sheet melts completely. And as these kicks get stronger and the melting speeds up, that number stops being some far-off threat and starts becoming a very, very real problem for every single coastal city on this planet.
So where does that leave us? What do we do now? Well, the researchers behind all this work left us with a really powerful and frankly pretty sobering analogy for how we should be thinking about this. The wolf is here.
Their message is crystal clear. This isn't a story about a wolf that's coming. It's a story about a wolf that's already in the village. Think about that. We are living in this new, unstable climate right now. This isn't some problem we're kicking down the road for our grandkids to solve. No, this is a crisis for us, today.
But here's the good news. There is still a path forward. We can still weaken that push. Now look, we probably can't stop the kicks from happening. Those are just natural weather events after all, but we absolutely can weaken the push. By drastically, and I mean drastically, cutting our emissions, we can slow down that background warming. We can start to pull the Arctic back from the edge of that cliff and make those kicks a lot less damaging when they do happen.
When you boil it all down, the Arctic is our planet's thermometer. And right now, it's not just running a little warm, it's burning up. It's signaling a really dangerous fever. So the question this research leaves us with is simple, but it's also incredibly profound. Now that we can clearly see the reading on the thermometer, what are we, all of us, going to do to cool it down?